In this video, we are going to be dividing mixed numbers by converting them to improper fractions. So in the previous video, we learned how to divide fractions. Well, when we're dividing mixed numbers, it's the same thing, but we just have to make sure we convert the mixed numbers into improper fractions before we can do the math. Let's first talk a little bit about what division is. Let's look back at that question about the trail mix. If you have 2 1/4 pounds trail mix, how can you find how many 1/8 pound servings you can make? So if I have 2 1/4 pounds of trail mix, I'm essentially wanting to make groups of 1/8 pounds. So I'm taking that 2 1/4 pounds and dividing it into groups of 1/8. And really the question's asking us, how many of those groups can I make? So how many 1/8 fit inside 2 1/4? Well, let's look at a model, because we can use a model to figure this out. In front of you, you can see 2 wholes and 1/4. The wholes are made up of fourths, and there's 4 fourths that make up a whole. And here I have 2 1/4. So this 2 1/4 is my trail mix. I want to take these 1/8 pieces over here. I want to take the 2 1/4 and divide it into these 1/8 pieces. So how many 1/8 pieces fit inside 2 1/4? Well, I've noticed that 1/4 makes up 2/8. I'm even going to write that. 1/4 is equivalent to 2 of those 1/8 pieces. So if I have 2 wholes and 1/4, how many would there be? Well, if 2 fit inside this 1/4, essentially I have 2 would fit in here, 4, 6, and 8. So 1, 2, 3, 4, 5, 6, 7, 8. And 8/8 makes a whole. So I have 8/8 are here. Another 8/8 are in this hole. Because again, I can cut these fourths. Here's another 1/8. Here's another 1/8, another 8/8. So that brings me to 16/8. And then this one little 1/4 is another 2/8. So altogether, I could fit 16, sorry, not 16, 8 plus 8 is 16, 17, 18 pieces can fit inside 2 1/4. So 2 1/4 divided into 1/8 pieces is going to give me 18 1/8 groups. So I can take that trail mix, divide it into 1/8 sections, and I'd have 18 people to feed if I wanted to feed each person 1/8. I could feed 18 people that trail mix. We don't always have to use a diagram, but I wanted to show you and reiterate what division of fractions really is. We're taking that fraction and we're breaking it down. So this model pretty much helps us. But you learned in class how to do it mathematically. You can take 2 1/4 and divide it by 1/8. And we learned that really we could use multiplication and the reciprocal to help us find our answer. Now 2 1/4, well, that's a mixed number. So we can't do anything until we change that to an improper fraction. Now you learned the trick. You could do 4 times 2, and then you can add 1. So 4 times 2 is 8, plus 1 is 9. And you'd have 9/4. Another way I think about it is I think how many fourths make up 2 wholes? What number divided by 4 equals 2? So I know 2 wholes is 8/4. And then 8/4 plus 1/4 gives us this 9/4. Either way, it's your choice. So 9/4 divided by 1/8. And then, as you learned in class, when we're dividing these fractions here, you can actually use multiplication. The opposite of division is multiplication. So we can take our first number, 9/4, and we can use multiplication instead of division. But remember, we're not going to multiply by 1/8. We're going to multiply by the reciprocal of 1/8, which is basically just switching the numerators and the denominators, flipping it around. So 1/8, the reciprocal of 1/8, is 8/1. And then we simply multiply across. 9 times 8 is 72. 4 times 1 is 4. And 72/4 is our 18 wholes. I know. Some of you are saying I did way too much work. And you're probably right. Because many of you realized that I could cross cancel. Good job in remembering. So I noticed that my denominator of 4 and my numerator of 8 have a common factor of 4. 4 divided by 4 is 1. 8 divided by 4 is 2. 9 times 2 is 18. And then 18/1 is our 18 again. Now remember, you don't have to cross cancel. You can choose to do that, or you can choose to multiply the other way. Cross-canceling helps make the multiplication much smaller. So if you struggle with multiplication, it might benefit you to cross-cancel. But if you just want to multiply the numerators across and the denominators across and then simplify, that's fine too. Let's look at one more example. 3 1/3 divided by 1/6. What is this question really saying? It's saying if I have 3 wholes and 1/3 and I want to divide it into groups of 1/6, how many groups am I going to have? In other words, how many 1/6 pieces fit inside 3 1/3? You can draw a diagram, you can use fraction strips, you can use any sort of strategy you wish. I'm just going to use the strategy of multiplying the reciprocal. But I notice that I have 3 1/3 and it's a mixed number. So I'm going to take this 3 1/3. I know 3 wholes is equivalent to 9/3, and 9/3 plus that 1/3 is 10/3. You could also do the trick of multiplying 3 times 3, which is 9, plus 1 is 10/3. So 10/3, the division becomes multiplication, and my fraction here, my 1/6, I can use the reciprocal, which is, you got it, 6/1. So now I have 10/3 times 6/1, or 6 wholes. Now you could just multiply across. 10 times 6 is 60, and 3 times 1 is 3. 60/3. I can't leave it as an improper fraction. We never leave it as an improper fraction. We're always going to simplify it to its lowest terms. And 60/3 is actually another way of saying 60 divided by 3, which is 20. Now, I don't have 20 wholes. 20 wholes is not my answer. What does that number 20 represent? You got it. That number 20 represents how many 1/6 pieces can fit inside 3 1/3. So for instance, if I was taking 3 1/3 cakes, 3 whole cakes and 1/3 of a cake, and I was dividing those cakes into pieces that were equivalent to 1/6, I'd have 20 pieces to give my friends. But I don't have 20 wholes, so don't be mistaken by that. It's just saying that I have 20 1/6 pieces. Now, some of you probably noticed, in order to get that 20, we didn't have to do all that multiplication. We can actually have cross-canceled. I noticed that 3 and 6 have a common factor of 3. So 3 divided by 3 is 1, 6 divided by 3 is 2, and therefore we can now multiply our numerators, which is 20, and our denominators, which is 1. And 20 wholes is, just like our previous answer, 20. You get the same answer, you can just get it in different ways. Alright, let's remember this. When dividing fractions, make sure you keep the first fraction, change the division to multiplication, and use the reciprocal of the second fraction. Some of you call it keep, change, flip. But remember, always watch this video when you want to really understand why we use keep, change, flip. Keep, change, flip is just a trick. It's not the actual understanding of the math. Alrighty, here's your independent practice. Here are 2 questions. Make sure you pause the video, copy the questions, and show all your work. Bring into class to get credit for homework. I'm going to read the questions out loud to you so that you can understand them. The first question says, Sheila has 10 1/2 pounds of potato salad. She wants to divide the potato salad into containers, each of which holds 1 1/4 pounds. How many containers does she need? So essentially, think about what amount do you have, and then what are you going to be dividing it into? All right, now explain this error. To divide 14 2/3 divided by 2 3/4. Eric multiplied 14 2/3 times 4/3. Explain what he did incorrectly. That's a hint. He did something wrong. So try to figure it out. Hope you enjoyed this video and hope it has helped you.